All right, as we finish reviewing for your exam coming up in our next lesson, we reviewed a lot of things yesterday. Want to go ahead and finish reviewing today. And one of those things that we need to go over are your constructions. You'll have just a couple of them, so it's not going to be, super construction heavy. You've already had a test over constructions, but you will have a couple. And they will be one of your first 5 constructions. So let's review those. If you would have some paper out. Also have out a compass and straight edge. Also have out your compass and straight edge. And Jamie, you have had the opportunity in watching YouTube videos to laugh at your classmates as they have tried to explain how to do constructions. And we have never had the opportunity to have Jamie walk us through a construction. So, Jamie, go and unmute your mic, and we're going to have you help us with this one. If you would, all of you at your seats, Jamie's going to talk us through, but all of you at your seats, go ahead and draw an angle on your paper. And Jamie, I want you to walk me through the steps. How would I bisect an angle? How do we bisect an angle?
You would put the point of the straight edge on the vertex and make an arc. Oh, with a compass.
Oh, compass. Okay.
And make an arc through. Put the compass smaller.
Okay.
And then make an arc through both sides. And then you put the point of the compass on one of the intersections of the arc and make the compass smaller. And then make an arc the other way too. Through the first arc. And then redo it, put the point on the other intersection and make another.
Open it more?
Keep it the same amount.
Okay, so go here and then like that.
Do another arc through the other 2 arcs.
Okay, but really, truly, Jamie, it doesn't have to come through this first arc that we drew, as long as these 2 arcs can intersect each other out here. And I don't know how well the blue is showing up there on the screen, but yeah, as long as you can get these 2, let me highlight over the arcs. As long as these 2 arcs will intersect somewhere out here, that's all that really matters. Then what do?
We draw a line through the 2 points the 2 arcs intersected at, right there.
Okay.
From the vertex.
From the vertex. All right. So with the straight edge connecting the dots. Good job there, Jamie. And I trust the rest of you had this as well. Only one thing I will say is out here, Jamie had me close the compass a little bit. That wasn't necessary. And in fact, with an obtuse angle, Jamie, you may have to actually open it a little bit more. Again, it's just that way the 2 arcs can crisscross up here. So sometimes that involves opening the compass a little bit more, but otherwise a great job there. Let's see. Let's go ahead and go to Chris. And Chris, I want you to, all of you drawing the line. Chris is going to talk us through here. See, it's something about he didn't want to get picked. I saw that in the chat just a moment ago. And so let's go and draw a line segment. And first, I want you to walk me through how would we construct the perpendicular bisector of this line segment?
So you would take your compass and you would put the point of the compass on one of the endpoints. It doesn't matter which one you do, and extend it a little bit more than half. And now make a mark. And now put the point of your compass on that mark.
Ooh, okay, no. Let me pause you there. You do want to open it more than half, but you're going to make an arc up above the line, not on the line.
Oh, okay, yes, sir.
And not just above the line, but also
below the line.
Below the line.
Now you're going to put the point of your compass on the intersection you just made.
What intersection?
Like, oh, you didn't cut through the line, did you?
Right, you don't want to necessarily cut through the line.
All right, do not close your compass. Do not close your compass.
Right.
Put the point of the compass on the other endpoint that you did not use. And now make an intersection with the top and bottom of the line that you just made.
Oh, the arcs, right. So make an intersecting arc up there. Also make an intersecting arc down here. And then, of course,
Connect the dots.
connect the dots. And there we go. So again, try to keep the arcs off of the line because otherwise you're going to find yourself wanting to move the point of the compass to an arc somewhere on the line. Just keep the line free of arcs, arcs above, arcs below, and that's all we really need there. All right, let's go to Audrey next. And Audrey, well, all of you again drawing, but Audrey's going to talk us through. Draw a line, and then if you would, pick a point somewhere in the line. Audrey, closer to the left or closer to the right?
Left.
Left, okay. You're one of those left-leaning people, huh? And do we want to go really close to the end or more toward the middle on the left side?
Towards the middle.
Towards the middle. Okay, so right about here look good?
Sure.
So on the left side, to kind of toward the middle too, all right. Well, I want you to tell me, Audrey, how we would construct a line perpendicular to this one at that point.
You would put the point of the compass on the dot. Then you would make the compass smaller than the line.
Smaller than this line, so like this,
Sure.
okay?
And then you keep it on there and you make an arc. And then you make an arc on the other side. You can extend your line.
Okay, I can actually, yes. Now, I was being a bit of a smart aleck here, Audrey. When you said shorter than the line, not shorter than the whole line, shorter than whichever side is shorter. So ideally, we open the compass so it's, less than the shorter piece. But you could extend the line, couldn't you? Way to not be thrown off by it. I'll do what Audrey says here. And that's always a good move, right, Kendall? And then we're going to extend the line there. Okay, and now what, Audrey?
You would open your compass wider.
Good. Make sure on this construction you open the compass a little bit extra.
Put it on the dot. And then make an arc above the line. And then make I'm not sure what to do.
Yeah, we're not going to put the point of the compass stays on the point to make the first two arcs. Once you've made those arcs, now we want to use those arcs, obviously. So we're going to put the point of the compass not on the dot. We're going to move it off the dot and put it on the intersection here. So we've opened the compass wider, and now we
Make an arc above.
good, and then
You would switch to the other intersection and then make another arc.
there we go. All right, and then of course
Connect the dots.
there we go. All right, so definitely some rust we're shaking off here on these constructions, but that's why we review, right? So that means tomorrow you don't feel the rust. You go ahead and feel it today. Let Genesis come back in. We lost her. All right, let's see here. Speaking of Genesis, there she is. All right, Genesis, welcome back. We missed you there for a few minutes. We're going to call on you while you're connected and have you help us out here. At your seats, all of you want to go ahead and draw a line. And this time, if you would, pick a point somewhere, tell you what, above or below. We'll let Genesis pick.
Above.
Above, all right. Way above or just a little bit above?
Just a little bit.
All right, good choice. All right, pick a point just a little bit above the line. And Genesis, we want to construct a line perpendicular to this one from that point.
Okay, so you take your compass
Okay.
and you put the point of the compass on the dot and you extend your compass past the line and then you make a Mike Wazowski.
All right, so make a nice big smile with the one eye. Very nicely done. Okay.
And then you go to each intersection. Well, you go to one intersection and you make an arc at the bottom. Oh, big one. And then go to the other arc. Or I mean the other intersection. and make an intersecting arc with that one you made at the bottom, and then connect the dots.
All right, perfectly done. Nicely done, Genesis. Gentlemen, let's keep the chat for profitable use as opposed to clowning around so you can stay focused during the exam and not be a distraction. Good. All right, last construction, and I would love to pick on Ethan here just because somebody said something about Kendall getting out of it. But but unfortunately, I'm too lazy to keep reading Ethan's comments. And frankly, I really don't want to hear what Ethan has to say. So I'm just kidding, Ethan. But Kendall, you're up, and we'll have you take the last construction for this review. All of you draw an angle. Yeah, he's faking the whole broken microphone anyway. Go ahead and draw an angle there at your seats. And Kendall, we want to take whatever angle we just drew and copy the angle. Make another angle that's equal to this one. Walk us through the steps here, Kendall.
So you start by making a line.
All right.
And then you put your point of the compass on the given angle on the vertex. And you make an arc intersecting both sides. And then you go to the line.
Hold on, I'm having a hard time drawing the arc. Can I open the compass a little bit?
Oh, yes.
Okay. All right. I want to make sure you only open it a little bit, not way out here or something, but a fair amount here. Of course, once you've made this arc, then you don't want to mess with the compass again.
And then you put the point of the compass on the other line. And then you make an arc. A little bit bigger to the left.
Well, make sure we put it not just on the line, but at one end point of the line, right? And then
Yeah.
a nice big arc that actually does cut through. My compass keeps slipping. That will go through the line at some point. So yeah, put it one end point and a nice big arc that will at some point cross over the line. All right.
And then you measure the arc.
How do I measure it?
You put the point of the compass on the intersection. And then you measure across.
To the other intersection.
Yeah. And then you mark it off.
By the way, class, this little marking is so important. Make that mark. I still see on the last test, I think we had this construction. Several of you were not making that mark. Make that arc so you know it really is the right measurement. Okay, then what?
And then you don't close it.
Good.
And then you put your point of the compass on the intersection of the other line. And then you make arc intersecting the other one. And then you just connect the dots.
Good. This end point that you started at back up here. And there we go. And I will give a tip, and I was hoping Kendall would call me on it. When you draw your first line, make it sort of, level with the first line. If this line had been angled, then drawing an angled first line would be good. But it helps you to visualize, because if your other angles like this, you're like, wait a second, those don't look like they would line up, right? Whereas, okay, when it looks like this, now you're like, okay, yeah, the angle looks good. I feel like it's right here. It makes it a little harder to check, but it's not necessarily wrong. All right, any questions on constructions? Questions on constructions? You will not have triangle constructions on the exam. It would be a couple of these first 5. All right, of course, you've got those in your notebook that you can be studying over as well. Another thing that we need to talk through, you need to know your terms and definitions. Need to know terms and definitions, and I'm not sure of a good way to do this. Group chat might work. Are all of you on computers or are some of you on phones? Who's on a phone? Call out to me if you're on a phone right now.
Me.
That sounded like Audrey. Kendall, you as well? Genesis, you're on a computer? And I know Ethan's on a computer, right? Computer, okay. Jamie, computer or phone, tablet?
Computer.
Computer, okay, so you can type. Chris, you're on a PC. Okay, excellent. So Audrey and Kendall, since you two are on phones, typing is going to be really a pain for both of you. So I'm going to have you two unmute your microphones. Now, the other four of you are at a tiny bit of a disadvantage here because of typing, but it'll allow me to see who's done first. I'm just going to call out some terms, definitions. You can keep track of your own score, but since I love competition, we'll get at least some semblance of answers. Here's what we'll do to kind of level the playing field, though. If you get a question right, you are out for the next question. Still pay attention to it, but you're not answering the next question. So let's get started here. Again, if you're on a computer, you're typing your answer in the group chat. Do all of you know how to type in the group chat? All right, everyone's good to go typing in the chat. Okay, excellent. All right, so here we go. You can use shorthand, by the way, if it's shorthand that I've taught you, though, you know, symbol shorthand would be a bit of a pain, I suppose. Maybe use other abbreviations as needed. All right, so let's go through our terms and definitions here. What do we call any flat surface?
Plane.
Plane. Audrey and Ethan, your spelling's just too awful there. I can't give that to you. Genesis spelled it correctly, but she was still a nudge behind Audrey. So we'll give Audrey the point, and now Audrey, you set out for this next one. Y'all keep track of your own points. All right, what do we call the intersection of two planes? The intersection of two planes. Lines, Ethan, line is an intersection of two planes. An edge is what we call it in 3 dimensions, but in just 2 dimensions, an edge becomes a line. All right, Ethan, you're out. Audrey, you're back in. What term refers to the intersection of two lines? A point, Chris. Chris, not midpoint specifically, Genesis, but just a point. All right, Chris with the point, Ethan back in. Line segments will be equal if their blank can be made to coincide.
Endpoints.
I think I heard that. Was that Kendall? I heard endpoints. Leave your microphone unmuted, Kendall. I think I heard endpoints from Kendall on that one. Point for Kendall, drop out. What's a limited portion of a line?
Line segment.
Line segment. Audrey with the point, limited portion of a line. And of course, line segments are equal if their endpoints can be made to coincide. What do we call the point that divides a line into 2 equal segments? There we go, midpoint. Chris was the first one there, but several of you popping them up there. Midpoint. What do we call a line or figure formed using only a compass and straight edge?
Construction.
Construction. Audrey, wow, Jamie, that was some fast typing. You got the whole word out almost as fast. I'll give you the point as well, because you had to have been typing as she was saying that. So I'll give you a point also, which means both of you are now out for the next one, but point for both. A figure formed using a figure formed by 2 straight lines drawn from the same point.
Angle.
Angle. Kendall with the point. By the way, if you're typing, you can start typing before I finish. If you're speaking, wait till I'm done. But if you're typing, you can start typing before I finish the question. Kendall with the point. Angles are equal if their blank can be made to coincide. Angles are equal if their blank can be made to coincide. No, not their points. No, not their vertices. 2 angles are equal if their sides can be made to coincide. If their sides can be made to coincide. Let's see. What do we call an angle whose sides form a complete revolution?
Paragon.
Paragon. Audrey. 2 angles will be equal. Excuse me, 2 angles will be adjacent to each other if they have a common blank and a common blank between them. Common blank and common blank between them. Genesis, vertex and side. Common vertex, common side between them. Point for Genesis. Again, that makes them adjacent angles. The line that goes through the vertex of an angle and divides it into 2 equal halves or 2 equal angles is called the
Angle bisector.
bisector. Ethan got it up first. Point for Ethan, the angle bisector. What do we call an angle whose sides form one straight line? Straight angle, Chris. What do we call angles formed when 2 straight lines meet to form equal adjacent angles? Right angle, Genesis, very good. 2 angles whose sum is a right angle.
Complementary.
Complementary, Audrey. When two straight lines intersect, the non-adjacent angles are called vertical, Jamie, vertical angles, the non-adjacent angles when two straight lines intersect. An angle that is less than a right angle.
Acute.
Acute, Audrey. An angle that is greater than a straight angle, but less than a paragon. Nope. Nope. Greater than a straight angle, less than a paragon. Reflex angle, that was Chris. Reflex angle, good. Two angles whose sum is a straight angle. Supplementary, Ethan, supplementary angles. An angle greater than a right angle, less than a straight angle.
Obtuse.
Obtuse, Chris got it out just before you, Audrey. Kendall, leave your mic unmuted so you can just call these out quickly. If you're calling them out, I'm not hearing them because your mic is muted. What is 1/360th of a paragon?
Degree.
A degree, Kendall. You've been calling all these out. You've been winning all of them and wondering why I wasn't giving you the points. Just I couldn't hear you with your mic muted. All right, now you can start dominating, except you have to sit out this next one. What do we call the instrument used to measure angles? The instrument used to measure angles. Protractor, Genesis, protractor. Is it a geometric instrument? No, Ethan with the answer. No, it is not a geometric instrument because it's based on markings. What do we call a geometric figure bounded by three straight lines?
Triangle.
Triangle, Audrey. What do we call a line in a triangle that goes from a vertex perpendicular to the opposite side? A line in a triangle that runs from a vertex to the midpoint of the opposite side. From a vertex perpendicular. Jot this term down on a paper, the paper you've been doing those constructions on. The altitude. An altitude of a triangle runs from vertex perpendicular to the opposite side. Could it be a perpendicular bisector? It might be, but if it's perpendicular, it's called an altitude. What do we call a line in a triangle drawn from a vertex to the midpoint of the opposite side? That is a median of a triangle. Good, Ethan, median of a triangle. We haven't proven it yet, but what did we observe is the sum of the three angles of any triangle?
Straight angle.
I like your answer better, Audrey. Chris was first. Chris, you get the point for 180 degrees, but Audrey, I like your answer. A straight angle is the sum, so I'll give you both a point, which means you both have to set out the next one. What do we call a triangle that has at least two sides equal?
Isosceles.
Isosceles, Kendall. What do we call a triangle that has no equal sides?
Scalene.
Scalene, Audrey. What do we call a triangle that has a right angle in it? Right triangle, Chris. What do we call a triangle with all sides equal? Okay, I'll give it to you, Jamie. Equilateral. You mentioned the equal sign and accidentally got the shift in there, which got plus. Equilateral, Jamie, with the point. I know what you did there. Of course, props to the others for typing it out, though neither of you spelled it correctly. It's equi with an I, lateral. But anyway, I got you. What do we call the equal sides in an isosceles triangle?
Legs.
Legs. That was Audrey, I think, that just said that. If I was wrong and I heard the wrong person, then Kendall, give yourself the point, but I think I recognized Audrey's voice. What do we call the side in a right triangle that is opposite the right angle?
Hypotenuse.
Hypotenuse, that was Kendall for sure. Chris right behind her. What do we call the sides in a right triangle that make up the right angle? Legs, good, Chris. What do we call any figure founded, or any plane figure bounded by straight lines? Any geometric plane figure bounded by straight lines. Not a paragon, that's an angle whose sides form a complete revolution. It's really close. Polygon, a polygon, or P-gon is your abbreviation. What do we call the side upon which any polygon appears to rest?
The base.
The base. Ty, Ethan with the point. I think that was Audrey's voice I heard. What would we call an angle formed by extending one side of a polygon? An angle formed, exterior angle. Good, Chris. What do we call a line drawn in a polygon with 4 or more sides that joins non-consecutive vertices? Diagonal, Genesis, diagonal. A polygon that is equilateral and equiangular is referred to as a
Regular.
regular. That's what sounded like Kendall's voice. Regular polygon. Good. What do we call a closed curve in a plane, all of whose points are equidistant from a fixed point called the center?
Circle.
I'm amazed that y'all didn't get that typed before I finished. Audrey with the point, circle. Chris right behind her, but Audrey with the point. What do we call a line that has its endpoints on a circle? Too specific. Chord, Ethan, chord has its endpoints on the circle. What do we call a line that is drawn from the center to any point on the circle? Radius. Oh, Ethan, you just got one. So rad. I'll give it to you, Genesis. Yeah, Ethan, you can't get back-to-back points. All right, radius. Genesis with the point. It's okay, Ethan. What do we call the perimeter or the distance around a circle?
Circumference.
Circumference, that sounded like Kendall's voice. What do we call a line that goes through the center of the circle and has its endpoints on the circle? Ethan with diameter. Got that out before I finished. What do we call any limited portion of a circle?
Arc.
I couldn't tell which girl was first. So Audrey, Kendall, give yourselves both a point and both drop out for the next one. Everyone's in the chat now. What do we call an arc that is equal to a fourth of a circle? I'll give it to you, Chris. Quadrant. A quadrant is a fourth of a circle arc. What do we call the geometric instrument used for drawing arcs and circles?
Compass.
Compass. That was Kendall, I believe. What do we call an arc that is half of a circle?
Semicircle.
Semicircle, Audrey. What do we call the geometric instrument that is used to measure line segments? Compass, Chris. Compass. How would we describe two plane figures if they are of the same size and shape and can therefore be made to coincide throughout?
Congruent.
Congruent. Genesis just a hair ahead of you there, Audrey. What do we call the matching equal parts of congruent figures?
Corresponding.
Corresponding. Ty, Ethan, and Audrey. Let's see, it goes to all of our constructions we did. What do we call a statement that we accept without proof to be true? It's a general statement, I should have said, that we accept without proof to be true. Axiom, Jamie, an axiom. What is the process whereby the truth of a theorem or the correctness of a construction is established?
Analysis.
No.
Proof.
Proof, Kendall. A proof is the process whereby the truth of a theorem or the correctness of a construction is established. In proofs, we will use axioms as reasons sometimes. We may also use informal statements, things of that nature. Or we may also use a geometric assumption that we've accepted without proof to be true. Chris was just waiting on postulate. Good job, Chris. I'll give it to you. He's like, now. He already had it typed, I bet, and just hit enter. Hey, I didn't say you couldn't do it. For 2 questions you've been waiting. I know you've been waiting because you were banking on axiom being followed by postulate. That's why I changed the order. Anyway, what do we call a statement that is not self-evident but must be proven by a chain of deductive reasoning? No. An informal statement can often be proven by just a single postulate or axiom or another very easy It requires a lengthy proof, perhaps. A statement that is not self-evident, no duh about it. A
Theorem.
theorem. I'll give it to you, Chris. A theorem. Your spelling's rough, but yeah. No, you can keep answering, I suppose. I mean, you're just throwing your guesses out there. All the normal rules have to be out right now because, you know, it's Zoom. What do we do? What do we call a statement that may be easily proven from a preceding theorem?
Corollary.
Corollary. That was Audrey. Corollary. This is only for the typists. So sorry, Audrey and Kendall, you can't get this one. Typists, on your marks, get set. What does CPCTE stand for? Go. What does CPCTE stand for? Who has the fastest fingers? Ethan, chorus parts congruent trie are equal. I'll give it to you. You abbreviated well. Genesis typed it all out word for word, though with some spelling errors, but I'm going to give that to Ethan. All right. I was just like, there's no easy way to do that. What is the concept that a quantity can be equal to itself? What is that idea referred to as? Identity, Jamie, by the way, all of you back in, identity, the idea that a length, a quantity, object is equal to itself. What do we call the part of a proof that's not written down, but it's the pre-planning step in which a strategy is devised to complete the proof?
Analysis.
There we go, analysis, Audrey. What is the picture used in expressing a proof called?
Sketch.
Sketch, Kendall, a sketch. What do we call lines that are added to a figure to assist in completing a proof? Auxiliary, Genesis, auxiliary, ooh, even spelled right? Almost, I-A-R-Y, but auxiliary lines, great job there, one L. Yeah, you did double L instead of L-I. Anyway, auxiliary lines. What do we call a statement formed from a previously proven statement by interchanging the hypothesis and the conclusion?
Converse.
Converse. That sounded like Audrey, I think. I think so. Audrey, if I'm wrong, then don't give yourself a point. Kind of give yourself a point. But I think that sounded like you. What do we call a method of proof that begins by assuming the opposite of what's to be proven?
Indirect.
Indirect, Kendall, and then proves that to be ridiculous. An indirect proof assumes the opposite. It's also called proof by contradiction. I'll give it to you, Genesis. I'm really letting spelling errors go because we're typing as fast as we can, right? Contradiction. Is the converse of a theorem true always? No, Ethan says it is not always true. Theorem converses may be incorrect. However, if you take the converse of a blank, it is always true. You already got the last point anyway, Ethan. The converse of a blank is always true. Definition, good Jamie. Ethan's like, he's going to ask, is the converse of a definition true? I'm going to type yes. I tell you, cheaters never cross. For lines that are everywhere the same distance apart, therefore never intersect, are called. I'll give it to you, Genesis. Parallel is what you're trying to type. Parallel lines. Or you could just, if you hit a double L on your keyboard, it would look like parallel lines, and then I would have taken that as the symbol because it's the shorthand for parallel. What do we call a line? What do we call a line that intersects two or more other lines? Transversal. Ethan, have that one ready to go. Transversal. No. Okay, that's all the terms and definitions. Now let's get on to some other statements here. Other statements that we need to know. What are perpendicular lines, Chris? You can unmute and call it out.
Perpendicular lines are lines that intersect the angle and bisect the base. The top angle and bisect the base, right?
Not necessarily. What is a perpendicular?
They create right angles.
They make right angles. There are the lines that form right angles. All right, I just noticed you had perpendicular in there, so I thought I'd do that. Okay, so for these, I'm going to make a statement, but I'm going to leave out part of the statement. You fill in the blank. So you're going to probably have to wait until I finish to know what the blank is. The whole is equal to the blank. I'll give it to you, sum of all its parts, but I'll give you the word sum. Ethan was first. Through two given points, how many straight lines may be drawn?
One.
One, Genesis. Through a single given point, how many lines may be drawn?
Infinity.
Infinite. Good, Kendall. Listen carefully. I'll do it with, instead of drawing, I'll say it out loud. So listen carefully. If R is bigger than M, in fact, I will write this down. If R is bigger than M, and if G is bigger than R, what else must be true? No. No. G is bigger than M. There we go. You corrected it. G is bigger than M. G is bigger than R, which is bigger than M. So G is bigger than M because if the first is greater than the second is greater than the third, then the first is greater than the third. G is bigger than M. R can't be bigger than G. R is less than G. G is greater than R. R cannot be greater than G. What's the shortest distance between 2 points?
A straight line.
Straight line, Audrey. Jamie, right there with her. I'll give you the point also, Jamie. I think that popped up as she was saying it, so I've got to give you the point. The whole is greater than
Any of its parts.
any of its parts, Kendall. How many midpoints can a line have?
One.
I got an I from Ethan. I think you meant one, but Genesis was the first to type one, and she beat out those saying it. So point for Genesis. How many angle bisectors can a line have? One, Chris. If equals are added to equals, the sums are?
Equal.
Equal, Audrey. How many perpendiculars can be drawn to a line at a point in the line? Ethan, one is correct. If two angles are complementary to the same angle, then those angles are going to be blank to each other. If two angles are complementary to the same angle, then they are equal to each other, Genesis. Two angles complementary to the same angle are equal to each other. Angles that are supplementary to the same angle are equal to each other. Good, Chris. Equal to each other. Lines that are parallel to the same line are
Parallel.
parallel to each other, Audrey. Lines that are parallel to the same line are parallel to each other. There we go, Genesis. You got it there, but point for Audrey. Lines that are perpendicular to the same line are lines that are perpendicular to the same line are parallel to each other, Chris. Parallel to each other. What is the sum of all the angles about any given point? Chris, you're out. You got the last one. What is the sum of all the angles about any given point?
A paragon.
A paragon, or 360 degrees. That sounded like Kendall. 360 degrees, the sum of all the angles about a point. What do we call the sum of all the angles about a point, or what is the sum of all the angles about a point on one side of a straight line? I'll give it to you, Chris, but straight angle is what we would normally want, but I'll give you the 180. Straight angle is the better way to think of that. If you were to add any two sides of a triangle, that sum would always be blank the third side. The sum of two sides of a triangle is always blank the third side, greater than Genesis. The sum of two sides is always greater than the third side. So if I knew that these two sides were 5 and 8, then this side has to be somewhere less than 13. It could be 12, 11, 10, whatever, but it's got to be less than 13 because the sum of two sides has to be greater than the third side. If two straight lines intersect, which angles will always be equal? If two straight lines intersect, which angles will always be equal? If they're formed, yes, but we don't know they're formed. But when two straight lines intersect, we will always get vertical angles. I'll give it to you. Vertical angles, Ethan. Vertical angles are equal to each other. Who was the ancient Greek mathematician who put together the truths of geometry? Good Genesis, Euclid. What was the title of Euclid's 13-volume work? No, he didn't call his book Geometry. He called it the blank. The Elements. The Elements. Again, he had 13 volumes in which he laid out all the principles of geometry methodically. We took the first blank books and made our geometry book out of it. Our geometry book uses the first 5 Genesis books of the Elements. If in a triangle, if in a triangle, 2 angles are equal, then the blank are also equal. If in a triangle, 2 angles are equal, then the
Opposite sides.
opposite sides, Audrey, I needed opposite, OPP, opposite sides are equal to each other. An exterior angle of a triangle is always going to be blank, either opposite interior angle. Greater than Genesis. An exterior angle of a triangle is always going to be greater than either opposite. She's pumped about that one. Greater than either opposite interior angle, because Chris typed the word greater right behind her, and but she used the symbol. Greater than either opposite interior angle. If in a triangle 2 sides are equal to each other, then the
Opposite angles.
opposite angles are equal. Audrey takes it again. Opposite angles are equal. Through a given point, how many parallels can be drawn to a given line? Through a given point, how many parallels can be drawn to a given line? 1, Ethan, only 1 may be drawn. Oh, let's see here. That just about everything between yesterday and today. Have I reviewed everything there is to go over? What is the longest chord that may be drawn in a circle? The longest chord that may be drawn in a circle. Diameter, good Chris, a diameter, we showed that had to be true. We didn't officially prove it, but we did show using some logic that had to be true. We said the sum of all the angles of a triangle is going to be a straight angle, or 180 degrees. In general, though, we said that for any polygon of n sides, the sum of all the angles can be found using what formula? The sum of all the angles of a triangle can be found using what formula? N minus 2 times 180 degrees. The sum is n minus 2 straight angles. N minus 2 times 180 degrees. How would I find the complement of a 76-degree angle? What would I need to do, Kendall? Not for points, just asking. How would I find the complement of a 76-degree angle?
You subtract it from 90 degrees.
Right, you subtract it from 90 degrees. Now, back for points. If every degree can be divided into 60, 1/60th of a degree, we call a
minute.
Minute, Jamie, just ahead of you there, Audrey. A minute, point for Jamie. So then, if I had, say, 76 degrees, 48 minutes, I would need to borrow one of those degrees, so we have 89 degrees, and that 1 degree comes over here as 60 minutes, and then we could subtract. That's if we were finding the complement, right? We would subtract from 90, or we could borrow. In fact, if we were to subdivide a minute, we could divide it into 60. seconds, I'll give it to you. I'm not sure what the 18 was there, Genesis, but seconds went for Genesis. So if I also had, say, 17 seconds, I could borrow 1 minute from the 60, get 59 minutes, that 1 minute becomes 60 seconds. If we're finding the supplement, we would subtract from 180, but you got the last one, Genesis, so no point. 180. That's where the 18 came from. You were poised and ready for supplement. All right. Let me look at the exam real quick, make sure I've asked everything. Yeah, I think we've covered everything between the last 2 days in this session. Tell you what, if you felt really good about parallel lines, transversals, and angles from yesterday, go ahead and exit the group, the Zoom meeting. However, I did get a request earlier in the hour to go over this some more. So I'm going to give you just a few more problems like this. So again, you're free to leave if you want to leave, but you're also free to stick around if you want a little bit more practice. Let's suppose we know that, oh, I need to know points. I need to know points. Hold on. Who just left? Genesis? Man, I need to find out how many points we've got. Audrey, how many points do you have?
24.
24. Jamie?
8.
Only 8. Okay. Ethan? Ethan lost track. Chris? 26. And Kendall?
13.
13. All right. Sounds like Chris was the winner unless Genesis had more than 26. But we don't know because she left. All right. So anyway, sorry about that. I meant to ask earlier. So we'll say Chris was the winner. So Chris will use these 2 lines. And we'll say that C is parallel to H. That is all we know. We aren't given anything about a bisector. We're not given anything about anything equal. Just C is parallel to H. Let's number the angles 1, 2, 3, 4, 5, 6, 7, 8. Suppose I know that angle 8 is 114 degrees. And suppose I know that angle 1 is 126 degrees. At your seats, find angles 2 through 7. If 8 is 114 degrees and 1 is 126 degrees, find angles 2 through 7. And you do not have to stay and participate in this if you feel confident, but certainly want to give you the opportunity to make sure you're good with this on the exam tomorrow. And I mean, that's a little bit bigger and a little bit clearer on your screens now. First angle I would find is either angle 7 or angle 6, because we see that 7 and 6, either one would make 180 with 114. What did you get for angle 7? Kendall?
66.
66 degrees. And you should have gotten the same thing for angle 6, correct? They're both 66 degrees? Which was really poor planning on my part to have angle 6 be 66. But anyway, I'm just, anyway. So we should be good on both of those. We could also, following the same logic, get angle 2 very quickly. Chris, what did you have for angle 2?
I had 54.
Good, 54 degrees. All right, so let me go and write those in. Again, using straight angles, always a good strategy. Now there's another angle that should be really, really easy to find that you have to do absolutely no math whatsoever, Jamie.
Would 3 be 66?
Right, 3 is corresponding to 7, and it's also alternate interior to 6, so 3 has to be 66 as well for the same for either of those reasons. So that required no math. The other two angles will require some math. Audrey, how might we find angle 4? Actually, no, 4 we can get without math. How can I get angle 4 without doing any math at all? Because we're lazy. We don't want to do math.
Isn't it the alternate interior angle
Which one?
to 54 degrees?
Good. 54 is alternate interior to angle 4, so this must also be 54 degrees. And that only leaves angle 5, and there's a few ways you could approach it. But Chris, what do we get for the measure now of angle 5?
Yeah.
I'm sorry?
I got 60.
60 even. An even 60 degrees here. All right, how did we do on these?
I got all of them.
Chris got all of them, good.
I was a little stuck at first, but now I understand it.
All right, so Jane, you're good now?
Yes.
All right, getting a thumbs up from Audrey. Kendall?
I got them all.
Got them all? All right, well, exam tomorrow. I will have a short YouTube video up in which I'll go over the test just to make sure everyone's good to go on that. But otherwise, we'll see you Monday when you come on back. Have a great day.